Okay, good morning. Today is Saturday, October 18th. This is our special Saturday class. The first thing we're going to do is go over the do now exercise, which is a handout on two sides, okay? The most important, these, B through E should be pretty easy, but A seems to be unrelated. The question is, here is the graph of F prime. How do you know that F is continuous for all x or not? Okay? Who thinks they want to, that's probably that's the hardest question. It's based on the concept. Who thinks they know an answer? Go ahead, Jess, since you had something earlier before we started filming.
It is continuous because the graph can be traced everywhere, so it's continuous, making f prime of x differentiable, so f of x is continuous.
She's got the right idea. I think it needs to be communicated a little bit better. Who thinks they can take that and just turn it into, you know, make sure we get the point communicated? AJ, you want to go for it?
Sure. It's continuous because you can draw it without removing your pencil from the paper.
Yeah, but we don't need that kind of reference on the AP exam, even though you have the right idea. Grace?
Because f prime is differentiable, f of x must be continuous.
Yes, that's much better. Jack, what did you want to say? Okay, so let's learn how to communicate it properly, okay? This thing about drawing without lifting your pencil isn't going to cut it, even though that's accurate. So yes, the graph suggests F is differentiable everywhere in 3 to 9. Negative 3 to 9. In other words, there's a value for the derivative everywhere. Even at this point, the value has a derivative, even at 6. Therefore, F must be continuous everywhere. We talked about this before. If you've got differentiable everywhere at every point, then that means it was continuous at every point. That's that theorem right there, okay? Question about A. Okay, the rest of it should go full pretty easy. Where is the relative max audience participation needed? Jack?
X equals 7.
And can you tell me, give me the reason?
Because f prime of x changes from positive to negative.
Well said. I'm not going to write it down, but that's the reason. Very well said. That's usually a 2-point answer. Okay? Where is the relative min moving right along? No. I'm not seeing at x equals 2. Here's x equals 2. At x equals negative 2. Justify your answer. Give us one sentence that tells us why. F prime of x changes from negative to positive. How many people had that statement on their paper? You got it. Find the values where we have an inflection point. No explanation is asked for. Who'd like to tell us where are the inflection points? I'm seeing 3 of them. Matt.
2, 4, and 6.
At 2, 4, and 6. How did you know those were the inflection points? It didn't ask for an answer, so you would be correct, but I want to take it one more step. How do you know at 2, 4, and 6? Mehak.
Because concavity changes.
I'm sorry?
The concavity changes.
Yeah, but that's F prime. If it were F double prime, that would be correct. Let's be more specific about how you know. Jess.
The slope equals 0, and, the slope equals 0, and as the limit approaches x from either side,
No, you got the right idea, but you're making it too complicated. Connor.
The slopes of the tangent lines of f prime of x changes from positive to negative or negative to positive.
Very well said. Say it again.
The slopes of the tangent lines of f prime of x changes from positive to negative or negative to positive.
You know, at this point, F prime is, F double prime will be 0, 0, and undefined. Those are critical values. Put your hand up if you have 2, 4, and 6 for the answer. Great. All right, the last one. What's F double prime at 4? Go to 4 and find F double prime, and go to F6 and find F double prime. Who can give me both answers based on the graph? Grace.
0 and
Who's got a question about the graph problem? Now would be a good time to ask. Excellent problem. Jack,
Can you explain that?
explain what?
Can you explain why it's 0 and a prime?
Yeah, so here's f prime, right? And I want to, this is f prime, so the derivative of f prime would be f double prime. At 4, the slope of the tangent line is 0. The slope of the tangent line here is undefined. Somebody else with a question or comment about the activity, the first part of the activity. That is very AP style, 9 points, and so on. All right, let's get to that's a, sort of a wrap up of the lesson we just covered on relative extrema, okay? All right. The reason I picked this question, and only this question, is because there's traps here in terms of computation, okay, that you need to be aware of. All right, here we go. F prime of x equals 1 plus 4/3 x to the minus 1/3. Or f prime of x equals to 1 plus 4/3 cubic root of x. Put your hand up if you had the derivative correct. Good. Just because you had the derivative correct doesn't mean you got the problem right. Now, we need to find out where the derivative is 0 or undefined. And you're going to get 2 answers. Just by looking at it, where is f prime of x undefined? Just by looking at it right now. At x equals to something. 0. Put your hand up if you had the 0 for the answer. Good. Now, you set it equal to 0 to see if you get a place where it's undefined. And this is where a lot of people forget to do. It's some computation now. Let's see. -1 equals 4/3 cubic root of x. Cross multiply. -3 equals, -3 cubic roots of x equals 4. Cubic roots of x equals -4/3. Cube both sides. -64/27. It's all about the -64/27. Who had the -64/27? I'm impressed. Excellent. Yes. How did I get it was 0? I just look at it. If I plug in 0, my derivative is undefined. Just by, remember my thing about making my negative exponents positive. That allows me to see where it's undefined. Do you see why we've been repeating that over and over and over? And you missed that, and you probably didn't put it positive. Okay? Again, everything we talk about is for a reason, so you don't make the mistake. So we have we have now f prime, the first derivative test, is going to be -64/27 and 0. And now all you got to do is find the signs. You use your calculator here. Well, you know this is bigger than -1, so you could use -1, whatever. I got positive, negative, and positive. Can somebody verify that? And showing me that this is the relative max, and this is the relative min. So my answers are, since it asks for the xy coordinate, let's see. When I plug in 0, I get 0. That's the relative min. And relative max, I don't think I can do this in my head. Can somebody help me out? Plug in -64/27 into that. So I'll take a decimal. At Water, you have something for us? You got 0 when you plug in -64/27? I find that hard to believe. Jack?
32/27.
32/27? Beautiful. It's just plug into the original. Okay? Make a mark next to this. There's going to be a question on test number 6 where there's going to be one of each. One that you get from undefined and 1 point that you get from making it equal to 0, and which really affects your f prime chart. Jack?
So even though there's the +1 in the derivative, if the fraction is undefined, the whole equation is just...
Right. If you were to make this one big happy family, you would get something like, here's a mathematical explanation for why. Because if you would rewrite it, you would get this. Okay? Oh, sorry. It would be actually good if you could see it. If I were to make this one big happy family, do you see how you still end up with that in the denominator? So therefore, the whole thing. He asked a very good question. Okay? And Olivia, maybe if you had made the exponent positive, you still could have said, I don't know about undefined or not.
That's like what I was questioning too, like what is that?
Great point. Again, do you see where the fine points were today? And this, and on part A of the reverse side. Somebody else with a question or comment about the activity? Good. Open your book to page 304, 305, and we're going to work now on the homework on extrema and the mean value theorem word problems, okay? And what we'll do right now is, since you have the G key and you've graded your homework, we will take questions on that as needed. Sorry. Okay, we're going to go over now the homework. Who's got the first question for G about the homework page? 32. 32 is the one with x squared e to the x. Is that the one? Okay. So find all extrema of that. I believe that was the question. So 2x e to the x plus x squared e to the x. Factor out an x e to the x, and you get 2 plus x. Page stop, I'll keep going. So now, -2 and 0 are my critical values. So here's f prime, and let's check the signs. -3, negative times negative is positive. -1, -1 here will give me negative, and this is positive. So we have a relative max at -2 something, and a relative min at x equals 0 something. 0 is going to be 0, and -2 is going to be 4 over e squared when you plug it into your original function. Okay? Technically speaking, remember, as we discussed, the actual maximum value is this guy, and the actual minimum value is that guy. Okay? Who's got another question for G about the homework? Go ahead, Matt.
Can you 5 on the worksheet?
All of it? Or is there something specific you want me to deal with 5 from the worksheet? Part B?
Yeah.
That was the one I think you fell for the trap. Okay? All right, let's tackle that. So number 5, maybe we need to do A before we can progress to B, okay? So the answer for A, the derivative of A was negative 6x squared plus 6x plus 12 if you rearrange the terms, and you can do some stuff with it. If the relative max is 4, okay, it didn't say that x equals 4. The relative max is the y value. So in other words, y equals 4. You want to find out what x value goes with y equals 4. At a relative max or min, the derivative equals 0. That's the concept. We're going backwards. So take the derivative, set it equal to 0. Didn't we do that in the first part, though? Didn't we have to do that for increasing and decreasing? Can somebody tell me, for part A, what are the values that go on the number line in part A? Jack. 2 and -1. Okay, and what were the signs for the first part, Jack? What is it again? Class, can that be verified? Okay, so are the signs back? Oh, it was -1 and +2. Is that better, class? Okay. So look, Matt, look at the critical thinking here. Remember, the relative max is 4. That means that's the y value. If they wanted the x value, they would have said it occurs at x equals 4. Okay? And that was the mistake you made. You know at the relative max or min, the derivative is 0. At these two dudes, the derivative is 0. A relative max is going to occur at x equals 2. Okay? So the point where the relative max occurs is 2, 4. The rest is easy. You plug it into your original one and you solve for k. And that's how I got my answer. That's an excellent question to work backwards the concept of relative max or min. Who's got another question for G about the homework? Now would be a good time to ask. Jack? Yes? Good. Sarah?
Can you do number 23?
Number 23 out of the book? Number 23 says, f of x equals x times x minus 1, all of it squared. Did you do it out, or did you use product rule? Okay, so I can do that. f prime of x equals 1 times x minus 1 squared plus x times 2 times x minus 1 to the 1 times 1. Now factor out an x minus 1, and you'll end up with x minus 1 plus 2x, x minus 1 times 3x minus 1. Did I answer your question? Okay, great. Was there somebody else who had a question about the assignment for today with relative max and min? That would be a good time to ask. Grace. 28. I believe 28 had to do with something like the do now today. Grace, are you seeing the connection that there was probably two values?
Yeah.
Okay, did you have two values? No. Okay, so it's exactly like the do now. So x equals 0 is undefined. So you're going to have x equals 0. Okay, for your f prime. But you also have to set this equal to 0. Grace, stop and keep going. You got the concept? Could somebody tell me what it was when you set that equal to 0? Like negative something over something? It's probably in the G key, Katie.
27, 1 over 27.
Negative 1/27th? Yeah. Do you see how this problem is parallel to the do now exercise? And that's an important problem, okay? Alex, all set? Okay. Somebody else with a question or comment for G? Okay, ladies and gentlemen, we're going to start with today's lesson, okay? Today's lesson is called the second derivative test for extrema. Okay. First of all, let's learn the concept. The concept is pretty easy, okay? Mr. G, don't we already know the first derivative test? Isn't that what we learned to find extrema? Isn't that good enough? It is. So let's put down the first hint. The first derivative test that we learned for extrema always works when you're dealing with functions, with something that is a function. Okay? But not everything, every derivative is in form of function. Can somebody give me the classic example where the derivative is not a function? In what situation in calc is the derivative not a function? Or what technique? Jack, implicit differentiation. You already know what the activity today is going to be. The activity is going to be something in implicit differentiation where we cannot use the first derivative test. So, first derivative test, not applicable for implicit differentiation or with implicit differentiation. Mr. G, does that mean that we don't have any relative max or min? No. A curve that's not a function still has relative max and mins, okay? Think about it this way. If you have a circle, okay? Now, a circle's not a good example. If you have a sideways parabola, okay, a sideways parabola may have a bad example also, okay? Trying to find a maximum or minimum point, okay? They're tough. A lot of the implicit differentiation curves are tough to graph. That doesn't mean they don't have a maximum minimum point. I'll show you. All right. The second derivative test always works. Mr. G, do I have a choice which one to use in the homework that we're going to do in class today? Yes, you do. The first derivative test, if it's a function, is a lot quicker. Okay? Let's learn what the second derivative test says. It's pretty easy, and it should be logical. All right, here it is. Let's say that x equals a is a critical value of dy dx. Did you see how I wrote it? I didn't write f prime. I want it to be any curve, whether it's a function or not. You know that the derivative is 0 undefined at x equals a. Okay? From the first derivative. If you plug in this value of a into the second derivative, you can decide whether that value was a relative max, a relative min, or nothing. Watch how easy it is if you connect the dots. Okay? If you find f double prime of a, Mr. G, does that mean I have to find the second derivative? Yes, you do. If that's more work, then you stay with the first derivative if it's a function. If you find f double prime of a and you plug it in, and you get positive, a positive value. Think about it. This is a value where the derivative is 0 undefined. But the second derivative means what kind of concept, basic concept on a curve?
Concavity.
Concavity. What kind of concavity do we have when the second derivative is positive?
Upwards.
Concave up. So the derivative is 0 undefined, and it's got to be concave up. Who's connecting the dots already? What's the conclusion? Grace. It's a relative min. That's right. So if you plug in a number that's the critical value of the first derivative, it's got to be, it can't be any random number, into the second derivative, and you've got positive, then you can conclude it's a relative min. Who would like to tell me now, what's the second thing that goes here? The heck?
Sorry, if f double prime of a is less than 0,
Okay?
then its concavity is downward and the relative.
That's right. And these two, is the only way to do things with implicit differentiation is to use the second derivative test. You cannot use the first derivative test with implicit differentiation because there's two variables in the derivative. You can't do a number line with two variables. Okay? And that's how they'll test the concept. Okay, and the third thing, if f double prime of a equals 0, then no conclusion is possible. You don't know whether there's a relative max or a relative min. It's difficult to tell. And that's it for the theory for today. Okay? And that's it for the concept for today. Who's got a question for G? Okay, let's do some examples. Okay, we're not going to do many. The important thing is to decide whether you want to use the first derivative test or go into the second derivative test. Find all x and y coordinates of the extrema and classify. Let me take number 1. F of x equals e to the 2x minus x. Mr. G, we already know how to do this problem with the first derivative test. If we had not had the lesson today, we would have been in good shape. That's right. I'm going to see the second derivative of this is going to be pretty easy to do. When it's pretty easy, I can choose to go there. First derivative, 2e to the 2x minus 1. Second derivative. It's easy, so I'm going to go for it. Who would like to tell me what the second derivative is? Just by looking at it, please. Wes.
4e to 2x.
Ooh. Wes, I noticed something. 4e to the 2x is always positive no matter what. I'm thinking already that whatever points I get from this, it's going to be a relative min because it's always going to be concave up at that point. Let's write it out. So let's set this equal to 0. This is never going to be undefined. Let me find my critical values. 1/2 equals e to the 2x. Take the natural log on both sides and divide by 2. Mr. G, I don't know for sure whether this is positive or negative. It actually is negative, but it doesn't matter. It's if you had no calculator, it would be a lot easier to do a second derivative test. F double prime of 1/2 natural log of 1/2. Instead of doing the number line, plug it into the second derivative, and it doesn't matter whether you know how to do a computation. This is always positive no matter what you plug in. So therefore, since F double prime of that number is positive, we have a positive means concave up. We have a relative min at that point. Answer. There's where the x value of the relative in, the y value, I'm going to be cheap and just plug in f of 1/2 ln of 1/2, just to get out of it. Mr. G, can I use my calculator to find the value of that? Sure. Okay. Class, this would be a good question on the AP exam to ask just what the x value is of the potential extrema relative max or min. And it's a lot easier to do the second derivative test than doing the first derivative test in case you're not sure whether the value of that is positive or negative. Mr. G, for the problems, can I do it any way I want if it's a function? Yes. Katie.
So you know that e to the 2x times 4 is always positive?
That's right. Think about it. 4 is always positive, and e to the something is always positive.
But like, are you going to be able to tell just by looking at it for every function?
No, that's when that's right. It's a judgment call. If the second derivative is complicated, it will work, but you may not want to go there.
Okay.
Excuse me. Good question. Somebody else. Mr. G, again, if it's a function, do I have a choice? Yeah, you do whatever is easiest. But we're trying, you know on the exam, you're going to get hit with the implicit differentiation case, which will be today's activity. Let's do number 2. F of x is still a function, x squared minus 6 ln x. Find the x and y coordinates of all extrema. Okay? Alec, can you help me with the derivative, please?